Alright, so here's a little video going over some of this stuff. I'm not going to do every problem because I'll run out of time. But I will go over some stuff that, people might not know. So domain and range, that's an old question. You can look that up. There is a minimum. It's right there. Right? And solutions are x-intercepts. So I could just look on the picture and find my solutions of 2 and 4. I could have also done it by factoring. Some of you did that automatically. Increasing is where my graph is going up, which is from here to here. So from 3 to infinity on the x's. And decreasing is where my graph is going downhill. So from negative infinity to 3. So that was weird, but we've done it before. These problems, you can take a look at what I did there. I'll show you a couple of these. I wanted to do one hard one and a couple weird ones. So looking at the hard problem, you say what multiplies to make negative 60 and adds to be 11. So, well, there's a lot of things, but the answer is going to be 4 and 15. Because 4 times 15 is 60, and the negative is going to go in the 4, because that'll make a positive 11. Now, since this is a mean problem, and I know it's a mean problem because there's a 6 in front, well, there's a number in front of your x squared, that means that I have more work to do. That means that 4x and 15x are my inner and outer FOIL. So now I got to decide, do I make this a 6x times a 1x to make my first term, or do I make it a 2 and a 3? And since I look over here and neither of these are a multiple of 6, I prefer to make this a 2x and a 3x. Now, your last step is to say 2x times what will make one of these two numbers. There's your only even, so 2x and a negative 2. And 3x times what will make the other guy, a plus 5. And there's your factors. Now notice I didn't set it equal to 0 and solve, because that's not actually what these are asking. This just wants you to factor and you're done as soon as you do. Now this problem is kind of weird, but it follows this pattern. This is called difference of squares. If you ever have something squared minus something squared, it's a plus b, a minus b. So if I can rewrite this as something squared minus something squared, which I can, then I just have to write it once with a plus 11 and once with a minus 11. It's done. You FOIL that out and see. Number 10, very similar, except you have to remember the first rule of Factor Club, which is take out a GCF always. You see how they're both even? Well, as soon as I take out a 2, I get the thing I wanted, which is something squared and something squared with a minus between them. So I like to actually take the time and rewrite it. And now you do 2x plus 3 and 2x minus 3. Alright, on to the next section. Alright, now we're going to do the next problem, which is when you're solving. So it's a lot like the last problems, except when it equals 0, you're actually going to get two answers. Okay, so I'll do this one because I like this problem. I like it because you have to remember, you do not factor until you get it equal to 0. Like add 2 to both sides. There's no point in factoring until you get it equal to 0. So here, multiply, and we'll say what multiplies to make 6 and adds to be 7. That's going to be pretty easy, right? 6 and 1. Now that means that 6x and 1x are your inner and outer FOIL. So over here, we're going to set up our little factors. Now what's cool about this is 3x squared can only be made one way. Right? 3x and x, and then I distribute it. So I say 3x times what will make one of those 2, and it's a 2. And then 1x times what will make a 1x, and you get 1. And then I got to solve it. So this guy will say x is -2. And this guy, you can either write it out or do it in your head. And the answer is -1/3. There's my two answers. If I graphed it, those would be x-intercepts, which is pretty cool. Now here's a weird one, but it looks like difference of squares that we just talked about. Unfortunately, neither of those are a perfect square. But if I take the time and I remember to take out a GCF of 3, everything's divisible by 3, this will be 9x squared minus 4. Now that I can get on board with, because that's really like taking 3x squared and 2 squared. So it's going to be, that pattern is 3x plus 2, 3x minus 2. Now if you're wondering what do I do with a 3 in front, you pretty much get rid of it, because it doesn't have an x on it. And if you set it equal to 0, it doesn't make any sense. So let me try this other one. I'm going to go set this to 0 and set this to 0 and solve them. Now I can do these in my head. So this one's x equals -2/3, and this one's x equals regular 2/3. Okay, so just something to consider here. Let's go into the next chunk. Alright, so this chunk is working backwards. You start with the answers and you make factors and you FOIL them out. So this one's a little sneaky. I should have written double root on here, because the only way you can have one answer for quadratic is if you actually have it twice. It's where the graph hits just, in a weird spot. So if the answer is x equals 6, the factor is x minus 6. And you just FOIL it out. X squared minus 6x minus 6x plus 36. Combine like terms. Boom. This one's a little sneakier, but it really helps. You know this one's going to be an x minus 4. This one's a little trickier. You have to be, good at doing these in your head. First of all, I know the number on bottom goes on my x. The number over here goes there, and it's the opposite sign. So if that's a positive, I want negative. And then I FOIL it out. 3x squared minus 12x minus 2x plus 8. And combine like terms. There's my functions. Okay, let's go on to the next chunk. Alright, this next chunk of problems is a lot like what we were doing up here where we were solving, except since they're inequalities, you have to shade all the solutions. So you're still going to factor and solve. Only difference is, instead of those two being your answers, I have to decide, is it an open circle or closed circle? So I put a -1 here and a 4 here because it's left to right. Open circle or closed circle, and do I shade in or do I shade out? Now you can either use a test point, like plug in a 0 and see if it's true, or you can remember the go law, and greater than is or and less than is and. This is a less than, so I shade between them. That one was a greater than, so I shade outside. And they're open circle because it wasn't or equal to. So we'll break this down real quick. We'll do one here. This one, you could waste time or you could do it the smart way. Do you notice how a 2 goes into every one of them? So it looked like a mean problem, but it's actually a nice problem. So really what multiplies to make 3 and adds to be 4? 3 and 1, right? And since it's a nice problem, I actually have my two answers, x plus 3, x plus 1. Now, remember, if the number out in front is just a constant, you get rid of it. So here I'm going to say my two answers are -3 and -1. So I put them on a number line. I decide open or closed circle. I'm doing closed because it's greater than or equal to. And then I remember go LA, greater than is or, so I shade out. You could have also used a test point and plugged it in. If it's true, you shade towards it. So this one looks like a nice problem, and it is. What multiplies to make -21 and adds to be -4? negative 7 and 3, right? X minus 7, x plus 3. My two answers would be regular 7 and negative 3. Open circles, because it's just less than, and less than is and. So it looks like that. The next one says solve by graphing. Now you don't have to sketch a perfect graph. You basically got to do the problem the same as we just did, where you set it equal to 0 and factor it and get your two answers. Those are your two x-intercepts. And then this graph opens up, right? So when it opens up and I'm looking for where is my graph greater than 0, well, that's out here and out here. But I'm only concerned with the x's, so I make sure I shade out. So it's kind of like our answers before. Similarly, although I do warn you because I hate having a negative there, so what you'll see me do every time is take those all over and say x squared plus 5x minus 6. They all change signs. And then I can factor, I can say what multiplies to make negative 6 adds to be 5. That would be 6 and negative 1, right? And I'll have my two answers of negative 6 and 1. Those are my two x-intercepts. 1, 2, 3, 4, 5, 6. Boom. And now my graph goes up. Originally it was going to go down, but when I moved everything to the other side, I made it positive and I make my graph go up. I want to know what's crazy about this is when I switch sides, do you see how it actually is a less than? My graph is on the small side of the alligator mouth. So I actually want all this stuff below. So I want all the numbers between negative 6 and 1, closed circle, and I want the in-between stuff. So it's kind of like those last problems. All right, on to some radical stuff. We'll do kind of one of each. We're going to break this guy down. I want the biggest perfect square that goes in nicely. Remember to write these out when you first get your test. All the perfect squares. Well, I already know 100 goes in there. So I can rewrite this as 103. Radical 100 and radical 3. And then I turn that into a 10 radical 3. Okay, simplifying. Done. Adding and subtracting. You cannot add and subtract until they match. So I'm cool with this guy, but this guy can break down further. 9 and 2. So really it becomes 2 times 3 radical 2. And finally, you're like, what's 3 radical 2's plus 6 radical 2's? It's 9 radical 2's. You just add the coefficients. Okay, how about a multiply problem? Multiply these two, you get square root of 15 times 20 would be 300. Oh, we kind of just broke that one down. So you multiply what's inside, and then you reduce it. Okay. If you ever have a radical in the bottom, it's not okay, so you multiply top and bottom by radical 5. And this top times top will be radical 10, and the bottom will be regular 5. And that's okay. Just leave that as your answer. It's allowed to have radicals in top, not in the bottom. And here's the other two I didn't go over. There's that one and that one. So pause it and look at those. I guess that's the end of it. So I speed run this. So yeah, just remember you multiply number part times number part and radical times radical. And then you can simplify. Same deal here. You can't add them right, or you can't subtract them right now, but I can break down a 12 to be 2 radical 3, and then when I subtract them, I get 0. All right, hopefully you study hard, practice your factoring. I will talk to you later.